Hello, and welcome to my chemistry assignment by me, Avatar. Today we'll be covering the differences between alkanes and alkenes, the different functional groups, and how do you name compounds that contain these different functional groups, and then the differences between addition polymerization and condensation polymerization. So let's start cracking. What are alkanes? Alkanes are the simplest carbon compounds you can find, and they're composed of hydrogen and carbon. They're saturated, meaning they only contain single bonds, and this is the general formula. This denotes for every carbon atom you can find, there's twice the number of hydrogens, plus 2. Now this is octane. Octane is the most famous alkane you can find. It's used in cars. Now there are three main types, and the types depend on the arrangement of carbon atoms. There's linear, branched, and cyclic. In linear, the carbon atoms are arranged in a straight chain. In branch, there is an open chain of carbon atoms along with side chain of carbon atoms, as you can see here. And cyclic, the carbons are arranged in which they form a ring. When it comes to naming, there are two main principles. First, you count the number of carbons and then you attach the suffix "ane". Remember, when it comes to counting the carbons, you always do it in Greek. Now, if there are any branches, you always start counting the position of the branches in relation to the first carbon. As you can see here, there's 5 carbons here. So it's pent, and the suffix is "ane", so pentane. In this example, the methyl group is found on the second carbon, as it's closest to the first. So it's 2-methyl. As there's 4 carbons in the parent chain, so that's 2-methyl butane. Alkenes are very similar to alkanes, and they literally differ because they have a double bond. This is the general formula, and this denotes for every carbon atom there's twice the number of hydrogens. There are 3 main types, and again, they depend on the arrangement of carbon atoms. The carbon atoms in a linear alkene are arranged in a straight chain. In a branch, it contains atoms that are arranged in an open chain and in side chains, as you can see here. And in cyclic, carbon atoms are bound together and they form a ring. Because there's a double bond in alkenes, it prevents the rotation of carbon atoms. And because of this, you have compounds with the same molecular formula but different structures. Now there's 2 types of isomers, cis and trans. In cis, when the groups of atoms are on the same side, the compound, they're known as cis, and when they're on opposite sides, they're known as a trans, as you can see here. When it comes to the naming, it's fairly simple. You state the number of carbons, obviously in Greek. Then you state the position of the double bond in relation to the first carbon. Then you attach the suffix "ene". Now you have to understand, if it is an isomer, then you state whether it's cis or trans, and that's placed in the front of the name. As you can see here, there's 4 carbons, and the second carbon is where you find the double bond, so it's butene. However, it's trans. The atoms are on different parts of the compound, so we call this trans-butene. In this example, there's 5 carbons, and the second carbon is where you find the double bond, so you call this pent-2-ene. The difference between alkanes and alkenes, to summarize, is that alkanes have a single bond. This means they're saturated with hydrogens, as shown by their general formula, as we showed earlier. Alkenes, on the other hand, are unsaturated because of the double bond, meaning that all the possible bonds that could be created with hydrogen are not made. This is evidently shown by looking at the general formula in comparison with the alkanes. Now, the great thing about the double bond is not only can it create isomers, but also it's very reactive. So when conducting the bromine water test, alkene is added to bromine water, which is generally brown. In the reaction, the bromine water becomes decolorized because the carbon double-double bond is broken and reacts with the bromine. Now, in this part of the presentation, we'll be talking about functional groups. What is the different functional groups, and how do we name compounds that contain these functional groups? Now, what are functional groups? They're groups of atoms that change organic molecules in important ways. Or what I like to say it, they give them specific properties. For example, aldehydes, ketones, phenols, alcohols are all functional groups. And when it comes to naming them, there's generally two basic rules. You need to understand the name is composed of a prefix and suffix. The prefix is the number of carbon atoms in the parent chain that contains the functional group, and the suffix is based upon what type of functional group is in the compound. So here, this is a table of all the different functional groups, but this includes the suffixes. So for different functional groups have different suffixes. This is the alkyl group. The alkyl group is a functional group that is essentially an alkane missing one hydrogen. When it comes to naming, it's fairly simple. You state the position of the alkyl group in relation to the first carbon. You state the number of carbons that the parent chain has. So here, the third methyl is found on the third carbon here, and then there's 6 carbons on the parent chain. So it's 3-methyl hexane. In this example, we have 6 carbons here. However, there's 2 different functional groups, chlorine and methyl here. But the halogen, because chlorine is a halogen, it's given a different priority compared to the methyl or alkyl group here. So this is 1-chloryl, 3-methyl pentane. Aldehydes are basically a functional group that is composed of a carbonyl, an R group, and a hydrogen. Aldehydes are always attached to the first carbon, and their suffix essentially is Al. So the prefix will be the number of carbons, which is hexan, and then the suffix is L. So it's hexanol. Hydroxyls basically are normally compounds that contain hydroxyls are referred to as alcohols. Now, this is a group that contains an R group, an oxygen, and a hydrogen. There are 3 main types according to the number of carbon atoms that are attached to the carbon atom that is attached to the hydroxyl. So as you can see here, it's just 1, that's primary, secondary there's 2, and tertiary there's 3, as you can see there. When it comes to naming, it's fairly simple. You state the number of carbon atoms in the parent chain that contains the hydroxyl group, so it's 6 here. You state the position of the hydroxyl group, and then the suffix always ends in ol, so it's hexane 3-ol. Here, you've got 4 carbons, so it's butan 1, that's where the hydroxyl group is, and then the suffix ends in ol, so it's butan 1-ol. When it comes to ketones, I like to think of them as aldehydes that are not attached to the first carbon. In this case, it's a carbonyl attached to 2 R groups. When it comes to naming them, you just essentially state the prefix, which is the number of carbon atoms in the parent chain that contains the ketone, and then the position of the ketone. In this example, we state the position first, but you can state between the suffix and the prefix here. In this case, we have 5 carbons here, but the second carbon is where you find the ketone, so it's 2-pentane 1. Now understand that you always count, and always remind yourself that you count any functional group in relation to the first carbon, if it's only the functional group in the compound. In this case, the third carbon is where you find the ketone, but there's 6 carbons in the compound, so it's 3-hexane 1. When it comes to carboxylic acids, we'll call them acids, they contain a carbonyl group, an R group, and a hydroxyl. Naming them is fairly simple. Essentially, state the number of carbons in the carbon chain that contains the acid, and then you attach the suffix oic. So in this case, you've got 6 carbons in the parent in this chain, and then the suffix is oic, so it's hexanoic acid. In this case, it's 4 carbons in the chain that contain the carboxylic acid, so it's butanoic acid. Esters, what are they? It's a functional group that's derived from a condensation reaction between alcohol and an acid. The group is composed of a carbonyl, a carbon bonded with an oxygen, single bondedly, an oxygen bonded with an R group, and the carbon bonded with another R group. When you see this in a compound, you know this is an ester. Derivative is the same thing. Count the number of carbons and then attach the suffix OH. So this is ethanoate. So for this example, methylbutanoate, how did I get that name? So you first understand that this is the alkyl and this is the acid derivative. With respect to the acid derivative, you understand that that comes last. So the alkyl, you know that it has one carbon, so it's methyl, and with the acid derivative, you've got 4 carbons here, so it's butan, and then the suffix is 08, so it's butanoate. So it's methyl butanoate. Amines are a bit similar to alcohols because they essentially have 3 types, and the types are dependent upon the number of alkyl groups binded with the nitrogen. Primary amines have 1 alkyl group, secondary have 2, tertiary have 3. When it comes to naming amines, you first of all, it's fairly, you identify the R group, which is the attached to the amine, which is here, and that becomes your prefix. So in this case, it's propyl, and the suffix is amine. So in this case, it's propylamine. In this case, we see that there's 2 ethane molecules here. So you represent the prefix would be diethyl, and as the suffix goes, it's diethylamine. So in this example, you have a phenyl group. A phenyl group essentially is a benzene without a R group. Hydrogen without, that's replaced by a R group. So how do you name them? They're composed of 2 components. The first prefix is phenyl, and the second component, the suffix, is the R group. So here, you've got phenyl, and the R group is amine, so it's phenylamine. Here, it's phenyl, and then the R group is ethene, so it's phenylethene. Welcome to the third part of the presentation. In this part of the problem presentation, we'll be talking about the differences between condensation, polymerization, and addition polymerization. So what are polymers? Polymers are a sequence of subunits bonded to each other. Like these examples here, we refer to these subunits as monomers. The process in which these are conjoined are known as polymerization, and there's 2 types, addition and condensation. Addition polymerization is when 2 alkenes react to each other and form a polymer. In the process, a double bond is broken and the monomers conjoin together, forming covalent bonds between each other, as you can see here. So in this case, we see formation of polyethene. 2 ethene monomers react to each other, and the double bond is broken, and they are bonded to each other by the covalent bond there. This is the repeating unit. Now, what is the repeating unit here? This is basically the basic structural unit of the polymer, where the monomer is enclosed in a bracket like this, where there is an N that represents the number of units the polymer has. In this example, VCl, or vinyl chloride, reacts with another vinyl chloride, producing polyvinyl chloride. In this example, as we can see, the double bond is broken, and this is the polymer produced. I've denoted the repeating unit here, as in the N is 4, because I determined that there are 4 monomers in this sequence, as you can see here, 1, 2, 3, 4. Condensation polymerization. What is this? Condensation polymerization is when monomers with different functional groups conjoin together. In the process, an ester bond is formed and H2O is produced. Now, in this example, terephthalic acid reacts with ethan 1,2-diol, and it forms an ester, or in this case, a polyester. Now, this is the repeating unit of polyester, where the monomer of polyester is enclosed in a bracket, with this determining the number of units in the polymer. I've also attached the product H2O, or water, to show you that water is produced in this reaction. Now, why is condensation polymers different from addition? Because condensation polymers, they break down easier compared to addition polymers because of the ester bond can be hydrolyzed. Or in better ways, if you add water, you can break this down. Thank you for listening to this presentation and hope you have a great day.